Good morning, everyone. Today, my group and I, Aeropin, will be presenting our findings on crack monitoring. This assessment is part of our mini project for the Subject Construction Technology 2. For this test, we use a digital microscope. This tool helped us magnify the surface cracks and measure their width accurately. It's a non-destructive method, which means we did not harm the structure while collecting data. This made it perfect for use on an old building like QZAT engaging Jajali. We selected 4 locations on the slab for monitoring. All test points were on the concrete slab near the front area. The cracks varied in size, with widths ranging from 0.10 millimeters to 0.65 millimeters. Each crack was observed closely to determine whether it was stable or progressing. Here is a summary of the crack monitoring results. From our observations, we identified a range of crack types with different implications. The smallest cracks, such as the 0.10 millimeters and 0.15 millimeter cracks, are considered hairline or shrinkage cracks. These are typical in aged concrete and often form due to drying shrinkage or minor thermal expansion and contraction. While they're not dangerous structurally, they can still allow moisture to enter the concrete. Over time, this moisture can reach the reinforcement bars, causing corrosion. The 0.40 millimeters crack falls into a moderate category. Its spreading nature shows that it may be slowly growing over time. These types of cracks can be caused by live loads, flexural tension, temperature changes, or even minor settlement in the slab. If not monitored or repaired, they can eventually become severe and compromise the integrity of the slab. And most critically, structurally threatening active propagation cracks demanding urgent assessment. The most serious crack, measuring 0.65 millimeters, is a sign of active propagation. This means the crack may still be widening or lengthening. Such a crack could indicate structural stress, fatigue from repeated loading, or even insufficient reinforcement in the slab. If ignored, this type of crack could lead to larger structural problems, such as slab failure or water leakage to the floor below. Therefore, wider cracks must be treated seriously, especially in old buildings like this one. Based on our findings, we propose the following recommendations. Firstly, small cracks like hairline and shrinkage types should be sealed using surface sealants, such as epoxy resin. This helps block water and chemicals from entering the slab and prevents long-term damage. Secondly, moderate cracks like the 0.40 millimeters one should be repaired with pressure injection methods. Epoxy or polyurethane injection materials will help restore the bond inside the concrete and stop further widening. Thirdly, the widest crack at 0.65 millimeters needs urgent structural assessment. A qualified structural engineer should inspect this area to determine if there is any serious internal damage or load issue. If necessary, reinforcement or strengthening techniques should be applied.